Software architecture have never been static, but in the last few years, there is a rapid evolution of organizational and operation model. Early days we had a monolithic architecture when building applications, but now people are moving away from the monolithic architecture to the microservices architecture. This video is about journey from the monolithic architecture to the microservices architecture. Monolithic is a Greek word to describe a large single stone. Monolithic is made out of two words, monos and lithos. Monos means single and lithos mean stone. Altogether, monolithic is referred to a single massive software program in software architecture. Monolithic application is meant to use only a single programming language, a single repository, and a single shared database. Early days we had standalone application that has everything on it. It has user interfaces, databases, programming logic in one single system. These systems are much cost effective because its simplicity, easy to manage as it has a single application running on. It work well with simple software. If you need to scale up the system, you can simply increase the system performance by adding more powerful CPU and memory. But there are few problems associated with this architecture. If the system goes down, then the whole system is not available, which means there is a risk of availability. It works well for single users, but architecture does not support multiple users to work together in the same time at the same system. Engineers wanted much more sophisticated solutions to overcome this problem. So they have came up with a solution for this by separating the system into presentation layer and the data layer. Presentation layer contain applications that interact with the user and generate data. The data is stored in a remote database. So this allowed multiple users to connect to a single database and work simultaneously. This can be also known as two-tier architecture. The presentation layer is responsible for representing and modifying data, while the database layer stores the data in a central location. We can improve two-tier architecture to three-tier architecture by separating business logic into another separate layer. This new layer is called the business layer. Instead of keeping business logic in a single client computer, here we have separated it to another server. Now, multiple users can access the same service at the same time. And for the developers, it is much easier to give their business problem to the business layer. So they don't need to worry about any other layers. Layered architecture can be extended further into 4T architecture, 5T architecture, and so on. Generally, we can represent this as NT architecture. Let's have a look how typical multi-application work with a simple use case. Let's think about online shopping application. A customer need to buy a t-shirt from a shop. First, the customer get a list of available product from the shop and then customer can select what they need to buy. Once the customer confirm what they need to buy, then they can proceed to the payment and confirm the order. How we can represent this in a monolithic application? First, you need a database to store order information. Let's start with the database table. First, we need a table to store available products. In this table contain product ID to identify a particular product, the product name, which is the name of the item, available quantity of the product, and finally the price of each item. So not only the product, we also need to track the customer information as well. Therefore, we need another table called customer. In this table contain customer ID to identify the customer name, his address, and his email address. To keep order details, let's create another table called orders, and it contains order ID that can be used to identify the orders, the customer ID, which is the person who placed the order, the product ID, quantity of the products, and order status. Order status is used to track the current status of the order. Order status can be on created, paid, shipped, cancelled, and delivered state. If you need to show the product list, then you can read the product table and show it to the customer. When the customer wanted to place an order, then you can add an entry to the order table. The customer ID reference from the customer table and the product ID is reference from the product table. Of course, you can extend this idea to creating tables on handling payments, managing inventory, handling delivery as well. So let's keep it simple. We can keep all of these tables on a database. Then all the database accessing logic and business logic can be kept in a separate server. You can also keep the user interfaces as an HTML document. Look familiar? This is three-tier application. When software getting bigger and bigger, more components are need to be added. Your shopping application might need delivery management, inventory management, customer relationship management, financial management, and so on. Having all of this in a single business logic layer make a big mess. Tiered architecture does not give a solution for these growing system requirements. It is time to move away from the tiered architecture to the service-oriented architecture. Real-world applications are much aligned with services rather than tiers. Large application can be break down into multiple services. Let's think about what are the services and used in our online shopping application. First, we need some order management system to manage orders, payment gateway to perform financial transactions, CRM system to manage customer relations. Now we have a lot of services. How we can manage all of these services? How each of these services interact with each other? Here come the enterprise service bus, or in short, ESB. ESB can simplify the inter-services interactions. ESB is sitting in the middle of all of these services and handle all inter-services communication. Order requests from the client redirect the order management service. Payment requests redirect the payment gateway. Customer relation detail in the CRM system, and the list goes on. ESB is capable of routing requests between services. This will help you to orchestrate services and perform business operations. It can transform message from one format to another format or even communicate between multiple protocols. This architecture is much more simple, easy to manage due to its centralized nature. XML message format become the key ingredient of the service-oriented architecture. It is widely used SOAP messages, which is stand for Simple Object Access Protocol in inter-service communication. WSDL, which is Web Service Definition Language, become the contract defined among these services. ESB become the central component and greatly affect on other services. When times goes on, engineers wanted to remove the central component and decouple services more to improve the scalability. This path lead to a new software architecture paradigm known as the microservices architecture. Microservices architecture much similar to service-oriented architecture. You can have smaller services for each task, such as order management system to manage orders, payment services to manage payments, and customer service to manage customers. There are no central communication component in microservices architecture, and services communicate with each other by using a lightweight communication protocols. Asynchronous communication methods are widely used in microservices architecture, and we will discuss them later. There are many differences between service-oriented architecture and microservices architecture. Service-oriented architecture services are made in mind with reusing services, but microservices are more focused on decoupling services and work as independent components. This behavior is also lead service-oriented architecture to have a single shared database layer. But for the microservices, you need to have a separate database for each of these services to improve decoupling. Service-oriented architecture use many protocol in communication like SOAP, JMS, XML, but microservices use a lightweight protocol such as REST APIs and gRPC. Since microservices are much smaller than service-oriented architecture services, you can easily scale up and scale down the system as your requirement. In this video, we have mainly focused on what is monolithic architecture and how microservices architecture has evolved. In the next video, we will look more about microservices architecture and how it deployed into the cloud.